Today we're going to be evaluating and interpreting piecewise functions. So as we saw in the previous lesson, piecewise functions are a composition of, it can be several types of functions. We use linear and compare them to absolute value, but it's a composition of several different functions to make a new type of function, separated into pieces, a discrete, or it can be a discrete function. Okay. To evaluate piecewise functions, you're going to take your function and you're going to look to where the x value would apply to what piece. If you graph this, you can of course find the evaluation by graphing. We're going to do it algebraically by plugging in 9 first to the constraints. So, first, is 9 less than -4? No, it does not go on the top one. Is 9 greater than -4 but less than 0? No. Is 9 greater than 0? Yes, so we're going to be using the third equation. Our equation is the square root of x. We're going to put 9 minus 2. The square root of 9 is 3. 3 minus 2. And this is equal to 1. So in this piecewise function, f of 9 is 1. Okay, let's try -9. Plug it in for less than -4. Does it work? Yes. We're going to use the first one. Okay, notice this is a constant function. So if it's in this domain, no matter what we say the f value is, or the x value is, we can say -1 billion. The answer for the y value is still going to be simply -3. Okay, -4. Is -4 less than 4? It is not, it's equal to it. Try the second one. Is -4 less than or equal to -4? This part checks out, it is also less than 0. So we're going to use the second function. 2 times our x value, minus 3. This is -8 minus 3. So -11. Okay, number 8. I'm going to let you try number 8, actually. I'm going to skip down and do 9 and 10, 11 and 12. I might let you do number 12 also. I'll do 9, 10, and 11. I'll let you try 8 and 12, and I'll check these whenever you come back in and see if you have any questions on them. I do recommend you pause the video before I do these, though, to get some practice whenever you feel comfortable doing so. Okay, so number 9. F of -1. We're going to look at each equation. The first one, is -1 less than -1? No. Second one, -1 is less than or equal to -1, which is less than 1. This is correct. We're going to use the second equation. So, 4 times -1 minus 3. -4 minus 3, -7. -4. Is -4 less than -1? Yes, we're going to plug in the first equation. -3 minus -4. So this is really -3 plus 4 for +1. 8. Look at the last equation. Is 8 greater than or equal to 1? It is. So we have the cubic root of 8 minus 2. So what number cubed gives us 8? That would be 2. So we have 2 minus 2, which is 0. F of 3. 3 is greater than and equal to 3. So, or equal to 3. So it's the equal part. We're going to plug in the first equation. This is the absolute value of negative 3 times 3, which is going to give us the absolute value of negative 9, which is simply 9 units away from 0. Negative 3. Negative 3 is greater than negative 6, yet less than 3, so it's in between negative 6 and 3. We're going to use the second equation. Negative 3 squared minus 4. Negative 3 times negative 3 is 9, minus 4. This is going to give us 5. Negative 6. Negative 6 is less than or equal to negative 6. It's the equal part. This is the square root of negative 6 minus 1 plus 5. This is the square root of negative 7 plus 5. Okay, what do you notice right now? We can't take the square root of negative 7. This is not a real solution. It does not exist. You can also say, I was debating whether or not I wanted to show you this. This is the square root of 7 with an I out front, meaning imaginary, for square root of negative 1. 5 plus that. I am very happy with that answer. Okay. Number 11. F of 9. 9 is going to go into the bottom equation. The square root of 9. That's 3. Negative 9 is going to go in the first equation. Negative 1/2 times 9. This is negative 9/2. Okay, last one. Negative 4. Negative 4 is less than negative 1. It's going to be in the first equation. Negative 1/2 times negative 4. That's going to be equal to negative 4 over negative 2, which is just 2. I want to point something out in this. Through the questions we was asked, we never used this second equation. Y'all, that is okay. You do not have to use all three. Look to see what the function is wanting you to have, okay? Alright, I want you to try number 8, so I recommend pausing it if you don't want to get out the packet. So, write it down somewhere. I want to see when you come back, just to make sure you don't have questions. So, number 8. I also want you to try number 12.